This is Chapter 8, Air Masses by Taryn O'Connell. What is an air mass? An air mass is an immense body of air, usually 1,600 kilometers or more across several kilometers thick, characterized by generally uniform conditions. The temperature characteristics, moisture content, and stability across the horizontal extent of an air mass are similar. When an air mass moves out of its region of origin, it carries the temperature and moisture conditions elsewhere, eventually affecting the larger area. So this figure illustrates how an air mass can influence weather. In this figure, it's demonstrating where a cold, dry mass in northern Canada moves southward. At its source in near Great Slave Lake in northern Canada, its air temperature is bitter, negative 64 degrees Celsius. By the time the air mass reaches Winnipeg, it's a chilly negative 33 degrees Celsius. As the air mass moves southward, it has brought some of the coldest weather to the areas in its path. The air mass gradually got warmer as it moved out of Canada. Thus, this air mass was modified while the weather in the areas which it moved. So throughout this air mass journey, it brings some of the coldest weather to places in its path, while air masses itself becomes warmer as it moves southwards through the Great Plains and into Mexico. And the air mass impacts the weather in the areas over it which it moves, but it's also modified in the process. So these are some of the characteristics of an air mass. There are different locations under the influence of air masses experience some differences in temperature and humidity. A front is a boundary in a comparatively narrow zone that separates air masses having different densities, which result from the differences in temperatures and moisture content. An air mass weather is when it takes several days for an air mass to traverse an area, and the region under its influence generally experiences constant weather conditions. The characteristics of an air mass aren't perfectly uniform because it features such a blanket vast area. An air mass is a large bound of air having generally uniform conditions of temperature, moisture, and stability. Although some variations in temperature and moisture occur within the air mass, the characteristics of one air mass are quite unlike those in an adjacent air mass. Next is clarifying air masses. So source regions are the areas in which air masses originate because the atmosphere is heated chiefly from below and gains moisture by evaporation from Earth's surface. The nature of the source region largely determines the characteristics of an air mass. The source region should be an extensive, uniform area. The air masses form in regions where atmospheric circulation is relatively stagnant, so the air stays over the equilibrium with the surface, and air masses form when air is stagnant over a large area, take on characteristics of the water or land surface beneath them. A region having a highly irregular topography or one of the surface consisting of both large areas of water and land will not create uniform characteristics of the air above it. Regions dominated by stationary or slow-moving high-pressure systems, which tend to have light winds or be calm, are the sites of most, but not where all air masses develop. Next is this figure that shows source regions that produce the air masses most often that influence North America. The waters of the Gulf of Mexico and the Caribbean Sea and similar regions of the Pacific Ocean west of Mexico yield warm, humid air masses. In this figure, the major source regions are not found in the middle latitudes, but instead confirm mainly subtropical, subpolar, and polar locations. So the land area that encompasses the southwestern United States and northern Mexico is also producing a warm air mass, but much lower humidity. In contrast, the North Pacific and Northern Atlantic produce cool, humid air masses, and the snow and ice covered areas comprising them, North America and the adjacent Arctic Ocean, could produce cold, dry air masses. So next is the air mass classification. It normally depends on the latitude of the source region and the nature of the surface, oceanic versus continental. The latitude of the source region mainly determines the temperature conditions and lesser degree moisture content of the air. So based on temperature, polar air mass is a cold air mass that forms in high latitude source region. An Arctic air mass is a bitterly cold air mass that forms over the frozen Arctic Ocean. Tropical air mass is a warm, hot air mass that forms in the subtropics. And the nature of the surface in the source region is a maritime air mass, which is an air mass that originates over the ocean, relatively humid, and the continental air mass, which is an air mass that forms over land, which is normally dry. This is just a little graph of basically what I explained that's found in our textbook. And this is another one. So after an air mass forms, atmospheric circulation patterns eventually cause it to migrate from the area where it is acquired its distinctive properties to a region with its different surface characteristics. This figure basically just serves as a useful resource to examine the properties of the principal air masses with its source regions in North America, as well as those that directly influence our daily weather. So next is the continental polar and continental Arctic air masses. They're both very cold and dry in the winter. Continental polar air originates over the snow-covered interior regions of Canada and Alaska, poleward of 50 degrees north latitude, and the continental air forms farther north over the Arctic Ocean, which frozen most of the year, and Greenland ice cap. Lower temperatures distinguish continental Arctic air from continental polar air, although the difference may be just slight. These are some characteristics of continental, Arctic, and polar air masses. So winter characteristics, it's very bitter, cold, and very dry. Daytime sun is short-lived. It's not in the sky for very long, and if it is, it's very low. Water vapor content is very low, resulting in very stable air masses that produce clear blue skies and cold conditions. Some summer characteristics, which is like only continental polar, long days and the sun is at a higher angle than the winter. On the warm snow-free land surface, higher moisture content, but the air is so cool and like pretty dry, and brings present condition to the US for like a day or two. Next is maritime polar air masses. So maritime polar air masses are cold, moist, and form at high latitudes over the cold ocean waters, but compared with continental polar air masses in the winter, maritime polar air masses are relatively mild because the ocean surface is significantly warmer than the adjacent land masses. The temperature of the maritime polar air masses also tends to moderate more quickly as the air is moved equatorward. And then air masses that form in northwestern Atlantic tend to move eastward and impact the weather in Europe. Next is the Pacific maritime polar air mass. In the winter, maritime polar air masses that form over the Pacific Ocean often begin as continental polar air mass in Siberia. This source region is vast enough to allow air masses moving across it to acquire characteristics of a maritime polar air mass. As the air advances southward over the relatively warm Pacific water, evaporation adds moisture while surface heating warms its lower levels. It begins as very cold and dry and a stable air mass, and it evolves into one that's cool, humid, and relatively unstable. This is pretty much just a graph that shows during the winter maritime polar air masses in the North Pacific usually begin a continental polar air mass in Siberia. The air is modified and it slowly moves across the ocean. So most precipitation along the west coast of North America results from the wintertime storms that pass across the Gulf of Alaska. These storms are normally dominated by humid, cold maritime polar air. As this maritime polar air arrives at the west coast, it is often accompanied by low clouds and shower activity. And when the maritime polar air advances inland, it reaches western mountains, oceanographic uplifts, and can produce heavy rain or snow on wind slopes. So next is the maritime polar air from the North Atlantic. Basically, maritime polar air masses form the Atlantic may produce an unwelcome nor'easter during the winter. Summertime incursions of mild-time polar air masses bring pleasant weather. So basically the weather associated with a wintertime invasion of a maritime polar from the Atlantic is known as nor'eastern, and these strong nor'eastern winds, freezing or not near freezing temperatures, high relative humidity, and the likelihood of precipitation make this weather phenomenon an unwelcome event. Next is the maritime tropical air masses. Maritime tropical air masses affecting North America most often originate over the warm water of the Gulf of Mexico, the Caribbean Sea, and adjacent to the Western Atlantic Ocean. Most of them are warm and moist. The tropical Pacific is also a source of the region for the maritime tropical air. The land area affected by this latter source is small compared to the size of the region influenced by the air masses produced in the Gulf of Mexico and the adjacent waters. So maritime tropical air masses from the Gulf and surrounding waters are the primary source of precipitation in the eastern two-thirds of the United States. The average distribution of an annual precipitation for the eastern two-thirds of the United States could be shown by using isophyts. The pattern of the isophyts shows the greatest rainfall in the Gulf region and decrease the precipitation with increasing distance from the mountain region. Next is the Pacific Maritime Tropical Air Mass. Air mass from the tropical Pacific affects the weather along the coastal areas of the northwestern Mexico and the southern United States. If the air that is warm, moist air moves northwestward towards North America, cooling at the surface usually generates fog or low-lying stratus clouds that may produce drizzle or light rain. If the air mass is lifted over the mountainous terrain, moderate precipitation may result. Next is just a continued slide of the last slide. So atmospheric rivers are when there are times when the maritime tropical air, the subtropical Pacific, is associated with the winter phenomena. There are narrow zones in the atmosphere that transport significant amounts of moisture to regions outside of the tropics. The Pineapple Express is a popular atmospheric river driven by a strong southern branch of the polar jet streams and transports humid, warm maritime tropical air as far away from the Hawaiian Islands. So next is just two photos and a satellite image. The one on the left is the satellite image of clouds over the Pacific Ocean, just showing the Pineapple Express phenomenon, which is just a strong jet stream that carries maritime air from as far away from the Hawaii to the West Coast. Then the photo on the right shows clouds developing over the Sonoran Desert in South Arizona on a July afternoon. The source of this moisture is these summer storms in the maritime tropical air formed in the eastern Pacific. Next is the continental tropic air mass. So continental tropic air masses are more prevalent during the summer when you're over northern Mexico and adjacent to the parts of the arid southwestern United States is the hottest. Continental tropical air is unstable because of the intense daytime heating at the Earth's surface and significantly cooler aloft. It generally remains nearly cloudless because of the extremely low humidity and the presence of high humidity and the presence of the high pressure aloft that tends to limit consecutive lifting. The prevailing weather, therefore, is like hot with almost no rainfall. So basically, continental tropical air masses is mainly a summertime phenomenon that are just hot and dry. Although this air mass is usually confined to a source region, it occasionally can move to southern Great Plains. These two maps show the surface temperature and the surface dew point temperature. Use dew point temperature to determine the moisture content of an air mass. Closer dew point to the temperature, the higher the relative humidity. When the temperature and the dew point are the same, the air saturated in relative humidity is 100%. So the Southwest has a low dew point temperatures, meaning drier air, so the continental tropical air mass. Midsection has a high temperature and humidity, making it a maritime air mass. Next is warming or cooling an air mass. When an air mass moves over the surface with different properties, the air mass not only modifies the area it is traversing, but also is gradually modified by the surface on which it moves. An air mass that is colder than the surface it passes over will be warmed from below. This causes greater instability that factors in ascent of the heated lower layers, which contributes to the cloud formation and possibly precipitation. Air masses are modified by a surface heating, often exhibited by cumulus or cumulonimbus clouds. And if precipitation occurs, if genuinely consists of showers or thunderstorms. Next is the addition of or loss of moisture. These factors lead to instability and vertically ascending currents that rapidly transport heat and moisture to higher levels in a relatively short span of time. A cold, dry, and stable continental air mass is transformed into an unstable maritime polar air mass. So when a dry, cold continental Atlantic or continental Pacific air mass moves over a large expanse of the ocean, winter is greatly modified. Evaporation from the water surface rapidly transfers large quantities of moisture to the once dry continental air. Due to the underlying it is warmer than the air above. The air is also hazed from below. These factors lead into instability and vertically ascending currents that rapidly transport heat and moisture into the higher levels. Next is a vertical motion and stability. So upward and downward movements induced by cyclones, anticyclones, or topography can also affect the characteristics and stability of an air mass. These modifications are usually independent of the changes caused by surface cooling or heating. Air masses are modified by warming or cooling from below, the addition or a loss of moisture, and vertical air movements. On the windward slope, the moist air mass cools and forms clouds that frequently produce precipitation. As the air descends, the leeward side of the mountain is heated, resulting in a drier and warmer air mass that has a characteristic of a continental air mass: dry, warm, rather than cool and moist. An example of this is a significant modification which can result in an air mass drawn to a surface by a low pressure system. Next is the lake effect snow, cold air over warm water. The lake effect snow are snow showers associated with continental polar air mass to which moisture and heat are added from below as it traverses a large and relatively warm lake, rendering the air mass humid and unstable. The lake effect snow forms when the cold air moves over comparatively warm water or a large lake. They form within cold, dry continental polar air mass that was modified as it's moved from land across the open water. The stability and moisture of a continent of the continental polar air mass is modified as it travels and influences the weather as it continues to move. The areas most frequently affected are called snow belts, and they're shown in this figure. Next, when there is a dramatic temperature contrast, it exists that lakes interact with the air to produce major lake effect storms. This figure above shows the movement of the continental polar air mass across one of the Great Lakes. That is the end of my presentation. If you have any questions, please email me. Thank you.